Welcome to today's example. This is from 7.1, the first one in Chapter 7, which is on confidence intervals. I've got one very long example to work. As you read the example, I want to point out that most students do really well on determining if a question is a confidence interval, a Chapter 7 question, or a hypothesis test, a Chapter 8 question. Every once in a while, a student doesn't make the connection on one question and they go down a rabbit hole and get everything completely wrong. And there's really no way for partial credit. So one of the things I'm going to talk about as we do these examples is pointing out why this is a Chapter 7 question or why this is a Chapter 8 question. In this particular case, parts A, B, and C both use the word, or all three use the word confidence or confident. So it is a Chapter 7 question, a confidence interval question. As you read part A, one of the things that's interesting about it is it's not asking you to circle a confidence interval as your final answer, as most questions in Chapter 7 do. Instead, it says, how many helmets? And when you see a Chapter 7 question that asks for generically how many items, that is usually using the formula here. So our job to answer part A is to identify those four numbers. Now, Q hat is very easy because Q hat is just 1 minus P hat. So as soon as we find P hat, we'll be able to find Q hat. I usually leave ZC, the critical value, until the end because it's going to require a picture and the others don't. So let's look for P hat first. Sometimes P hat is given and sometimes it's not. In this particular question for part A, nowhere does it tell me what percentage of helmets were showing damage after a test. In fact, they even give you a hint and they say without any initial testing. So in other words, we don't know what P hat is. So only when you're using this formula, if you don't know P hat, you should say that P hat is 0.5. Any other formula, any other place, don't say, oh, I can't find it, it's 0.5. You go find it. So then Q hat is 1 minus 0.5 or 0.5. And then E, the margin of error, it says they want to estimate the damage of the helmets within 4%. So the margin of error is 0.04. Make sure you change it to a decimal. And that just leaves me the critical value. Now, for every critical value in Chapter 7, you'll draw a picture. The Z distribution is the standard normal distribution, which is bell-shaped and has a mean of 0 and a standard deviation of 1. This may not seem like a big deal right now, but it will make more sense in Chapter 8. In Chapter 7, all of your pictures should be what I call two-tailed, which means I'll draw tails on both sides. They should be about the same size. Your picture doesn't have to be perfect. Your confidence level goes in the middle. So it says they want to be 95% confident. So 0.95. Then each of your two tails, since they're supposed to be the same size, they should add up to 0.05. So each tail is 0.025. And one of these marks, the right one, we're going to label as ZC. Z because we're dealing with proportions, and the proportions follow the standard normal distribution. The C you can say stands for confidence, or you can say stands for critical value, whatever you want the C to stand for. That's the traditional letter that's used. We do want to use the right side because we're going to use this to later on calculate the margin of error. And by definition, the margin of error has to be positive. So we need it to be on the right side and not on the left side where it would be negative. So recall from Chapter 6, to find ZC, we would use norm.s.m because it's the standard normal. And the probability to the left is 0.975. I'll get this out of the way. Or if you prefer, you can use norm.m of 0.975, comma 0, comma 1. Either one will get you to the correct answer. And let's go to Excel. So I would encourage you, because you're going to have so many things going on, to label all of your work. So this is Z sub C. There we go, sub C. And either one of those two commands you may round to 2 decimal places to show your work, but you need to use all of the decimal places in your calculation, and I think that will make more sense in a minute. So it rounds to 1.96. So we have everything we need now to plug into this formula. So we have 0.5 times 0.5 times 1.96 divided by 0.04. Don't forget the squared. I don't know why in the last couple of years that has been a big goof that students have made, leaving off the squared. Now, as I mentioned a moment ago, you can round to 1.96 to show your work. However, when you type this into Excel, 0.5 times 0.5 times parentheses, you need to cell reference. Don't type in 1.96 because it's not exactly 1.96. You can get a different answer if you do not cell reference and then getting the wrong answer. So we get 600.2. But remember, we are supposed to round this up. So this is 601 helmets. Okay. Now, depending upon what you're doing, this could be a problem because that's 601 helmets that you're going to have to basically waste. You may not be able to sell those after you put them through impact test. So the company may decide, 601 was too much. So they said, well, screw that. And they tested 50 helmets for Part B, and 8 showed damage. And now it is asking you to construct a confidence interval. So Part B is still a Chapter 7 question. It talks about confidence, but in this case, it's the more traditional type of question where you're asked to circle a confidence interval as your final answer. I'm going to recommend these 6 steps for being able to do your confidence interval. If you printed out the OneNote PDF, then you've already got these printed out. So the 6 steps are: identify the parameter. In this class, that's basically mu, p, or sigma. Number 2, identify the statistics. Depending upon whether you chose mu, p, or sigma, it will tell you to use different formulas. So find the statistics in those formulas. Find the critical value, either ZC, which is what we're doing today, or TC, which is in the next lesson. Calculate the margin of error, and there's a formula for that. Construct a confidence interval, there's formulas for that. And then interpret the confidence interval, which we will talk about. So let's go through those 6 steps. So the parameter, it says construct a 95% confidence interval for the population proportion. So we're trying to estimate P. Then there are statistics that we need. I'll go back to the steps for the confidence interval to write it down. But for the formulas for the step 5, you have E equals ZC times the big square root of P hat Q hat over N. And then for step 6, you have the formula p hat minus e less than p hat plus e. So ZC is a critical value. It's not a statistic, but p hat, q hat, and n are all statistics. So we'll need to find p hat, q hat, and n. And then over here we have p hat. E is not a statistic. It's going to be what we calculate in step 5. P is a parameter, and we've already identified we need to find p hat. So we need to find p hat, q hat, and n. I always like to start with n because it should be the easiest usually. In this case, n is 50 because we tested a total of 50 helmets. 8 of those showed damage, so 8 out of 50, which I would suggest you write as a decimal, 0.16. So then Q hat would be 0.84, 1 minus 0.16. So those are the statistics that we need for this question. Step 3, which I think is the critical value. Yep, critical value. So again, critical values are going to require a picture. Since it is the standard normal, we have a center at 0. Since it's confidence interval, we have 2 tails. We label the right one ZC. And again, you have choices on how to find it. We have to label them amount in the middle. Notice this is still, in part B, still a 95% confidence interval. So my picture is completely identical to the one we drew in part A. And my critical value will be completely identical too, although that's not always the case. It is for proportions. Oops. If I don't use the S, I got to use the 0 and the 1. Okay. Step 4 is to find my margin of error, which we now have everything we need for that formula. And I didn't, yeah. So step 4. So we have 1.96 times the square root of 0.16 times 0.84 over 50. And since this is part B, I'll skip a line. It's still the same question, but calculate my critical value again, because again, I don't want a rounding error. We see we get the same error. So then E was the critical value. And again, you have to cell reference it. You can't type in 1.96. Sorry, my computer seems to be unhappy with me. Square root is squirt, except I forgot a times symbol. So 0.16 times 0.84 divided by 50. So we get 0.1016. One thing that's important to remember is that this is a proportion. So it needs to go to 4 decimal places. And then not the last step, but the last calculation is the confidence interval itself, which is p hat minus e less than p hat plus e. So remember p hat was 0.16. So back to Excel. So we have 0.16 minus, and again, you have to cell reference E because it wasn't exactly 0.1016, and 0.16 plus, and again, cell reference. So 0.0584 and 0.2616. Oops, and I left off the, should say 0.16. So there is my confidence interval. But again, we're not done because we're supposed to interpret what does the confidence interval mean in the context of the problem. I like to call these man on the street interpretations. For chapter 7 in particular, I think that any interpretation you write, any Joe Blow on the street should be able to understand. So we're not going to use, big statistical words. I always suggest the same format, if my pen will write, which it's not right now. There we go. So we are, I'll say, usually use the other way. We are 95% confident that and again, obviously 95% might not be the same every time, but that phrase basically stays the same every time. The next word here is, are we dealing with means, proportions, or standard deviations? Because those are our three choices, and this is a proportion question. So we are 95% confident that the proportion of, and then tell me, what were we counting? We were counting helmets that showed damage. So the proportion of helmets that showed damage, then from what? Of all helmets. And yes, it may sound a little awkward, but it does need to come where you say the proportion of helmets that show damage first and all helmets comes second. I know you could write it nicer and it would sound better, but it wouldn't be as clear if you switch that up. And then we finish it off, and it is between 0.0584 and 0.2616. So that is the actual construction of a confidence interval, going through all those steps. Now, the problem with this particular example was this number right here. Our margin of error was 0.1016. And back to the original question, they wanted the margin of error to be within 4%. And that did not happen. So that's why part C says the company is not satisfied with the interval. And they decide to do a new test. And it says how many helmets. So again, it's asking how many items. So we're using this formula again. But the difference between this and part A is that in part A, it said without any initial testing. And in part C, they are not satisfied with the results. So that means they have testing. Specifically, their testing said 8 out of 50 helmets showed damage. So the big difference with part C, is that P hat is the same 0.16 that we used in part B. which means that Q hat is 0.84. Now, comparing this to part A, E is still 0.04, and ZC is still 1.96 because we still want to be 95% confident. And you could recalculate that with another picture if you wanted. So we have E equals 0.16 times 0.84 times parentheses, and you can cell reference either of those two ZCs, but again, they do need to be cell referenced. So 322.7. But again, we round up, so we get 323 helmets. Now, that's still a lot of helmets to waste, but it's not nearly as bad as the 600 we answered in part A. So that helps. That gives you a pretty good overview of everything that can happen in 7.1. We did a how many items question where you didn't know P hat in part A, one where you did know P hat in part C, and then an actual construction of a confidence interval. As always, if you have any questions, please ask your instructor.